All right, everybody, here we go with the notes for Chapter 4, talking about recording and playback technology. Now, some of the stuff in this chapter gets a little detailed into some of the science and the tech aspects of the things that we do in the studio. Our purpose is to try to give you a rather brief overview so you at least understand some terminology and have a basic idea of what's happening kind of under the hood, if you will. One of the primary standard audio formats that is used for compact discs is called CDDA, and that stands for Compact Disc Digital Audio. Now, you're not going to see these files too much out there in the wild. It's kind of what's embedded into the CD itself. We don't really edit these a whole lot. You might see it if you take a compact disc and then you copy a file into your computer somehow. But basically, for your reference, the CDDA format plays back music with excellent fidelity, but it's not very good for real-time audio editing, which is why you don't see it very often. The data stored in the CDDA format uses uncompressed audio files. The standard CD, it can reproduce the entire spectrum of audio frequencies with a wide dynamic range, and it's nearly equal to live music. As far as what you hear from an audio CD, in terms of consumer music that you can purchase and play out there, it's as close as you're going to get on a consumer level in terms of true representation of sound. Now, this next section, again, we're going to try to do a brief overview on it. If you want to take a deeper dive, you see the pages in your textbook. Feel free to read through. As far as how we record digital files, digital recording technology takes the two components of all audio signals, which is frequency and loudness, and converts those components into mathematical representations called samples and quantization. Now, take a little bit into what those terms mean. Sampling is the process of converting audio signals, analog audio signals, into data. So it basically takes the analog audio and makes it digital. Basically, sampling involves taking a snapshot of an audio wave and breaking it down into very small segments of the signal that can be expressed in a form that a computer can use. So it's almost like taking a small slice of what you hear throughout different points of a particular audio file, and there's several thousand of those little slices that we take in each second of that audio that we're hearing. Humans can hear very low and extremely high frequencies, from a low of about 20 hertz, and that's going to be about the lowest of the notes that you might hear on a pipe organ, to somewhere around 20,000 hertz, and this is like the pitches that you're going to hear that come out of like a piccolo or a triangle or something like that. So that's kind of the range that we're working with, and if you ever look at the frequency response graph on many microphones, it's going to measure the range between those two values. The sampling frequency for good audio needs to be about twice the highest frequency that humans can hear. So the number that we tend to go by, 44,100 hertz, that's the number that we call the Nyquist rate, and that's basically the value that we've determined that is double our normal hearing capacity. So that's why we tend to use that as the broadcast standard. Again, the Nyquist rate, the official name for that value, 44,100 hertz. As the samples of the audio signal waveform are taken, they are converted into binary numbers in a process called quantization. The greater the amount of quantization, the better the sonic resolution, that is, the quality of the audio. So there you have it. We have this combination of things that helps us to be able to work with audio in these various technological sorts of ways. Now, One thing to keep in mind as we go into this discussion on disk drive recording, the book is going to describe the physical process that happens in a disk drive, and in that regard, it's talking mostly about mechanical disk drives with the spinning wheel inside them and all that sort of thing. There are solid state drives that tend to be more prominent in computers these days. We'll discuss those a little bit later, but just so you kind of understand where we're at this point, we're primarily talking right now about mechanical disk drives. Okay, so with that in mind, in the recording process, data is saved as a string of bytes, basically digital words, if you want to think of it that way. And it's saved in specific locations on a hard drive. As the information is written onto the hard drive, the computer creates a directory, what we call a file, and that file contains the locations where the data is stored. In computer parlance, we call these places on the disk sectors. So the actual physical spots on the drive where our data live are going to be in these different sectors. You might think of it as like, a neighborhood or something like that. So you kind of picture the physical spot on the drive where your data is living. Data may be spread across different parts of a hard drive. That data is accumulated within the computer in a buffer called a cache, and then it is transferred to the data registers within the computer. From there, the data is converted back into audio pulses by the digital to analog converter within the computer's sound card. So what it's saying there is that when you have say you have a Word document, and it's very possible that, we talked about the different sectors on a disk drive, or the physical place where your data live. It's possible that you could have a certain part of your data file in one sector and another part of that same file in another sector somewhere. Kind of like, if your house was somehow broken up and your bedroom was on the north side of town, but your kitchen was on the west side of town or something like that. That's how data tends to get saved in many of these mechanical hard drives. CDs and DVDs burn data onto a light-sensitive aluminum layer below a polycarbonate layer. A laser will burn a pattern of reflective and non-reflective areas that can be read by the laser during playback. So that's basically the manifestation of how we get the computer language, the ones and zeros, where it actually has all the information that is stored. That data is then going to be accumulated and converted back to audio, much like it is on a hard disk. Some common digital file formats that you're going to encounter, and these are going to be different types of files that will be able to work with most digital audio workstations like Adobe Audition. Now, digital audio workstations generally use the WAV format found on Windows computer systems, or the AIF file format that is found on Macintosh computers. Also, some audio editing programs use a modified version of a WAV called the BWF, the broadcast wave format. Basically, it's just another interpretation of a WAV file for your purposes there. The audio recorded in the WAV or the BWF or the AIF formats is what we call uncompressed audio. That means that recording and playback quality are excellent because the file is not compressed and shrunk down to try to fit into a smaller space. Basically the audio file takes as much space as it needs to in order to retain all the information in that particular file. Now, MP3s are much smaller than your standard files that we've already talked about. They are in a compressed format. So basically you can fit more content into a smaller file, but as a result, we sacrifice a few things. We'll kind of talk about that here in just a second. Another format similar to MP3 that does this kind of thing is called the OGG Vorbis file. Those are files with a .ogg as a format. Now, for our purpose, we'll talk about it as MP3 because that's the main compressed format that we're going to encounter. MP3 format compresses a music sound file. This compression scheme eliminates certain parts of a sound that the human ear cannot readily hear when it's being masked by louder sounds. So it takes information that really doesn't matter to most humans, that we wouldn't miss that stuff being there because we can't hear it, and takes advantage of what we can hear, keeps that information in order to help make that file smaller. The size of the MP3 file is a function of the quality level that the user selects. So the higher the bit rate, the higher the quality of the MP3. So when we talk about the different quality standards, basically this has to do with the amount of information that is contained within that file. And the more information that is there, the larger the file size, but also the more true to the original sound the file is going to represent. At this point, it's a good place for us to take a break. We'll finish up the chapter over on part B of chapter 4.